On the edge of a moonless night in Namibia, you look up. The desert air is thin, almost crystalline, and the sand holds no sound. A telescope hums behind you, a low mechanical breath, while the sky burns with a faint shimmer of old starlight. Somewhere out there, past Jupiter's wandering path, something green is moving. Not metaphorical green, not digital green, a color alive, like bioluminescence in a sea that forgot the ocean. 3-eye atlas, they call it. Or more precisely, 3-eye atlas, the third interstellar object ever detected by human eyes. A visitor from another star, another time. You don't have to believe in aliens to find that unnerving. You just have to believe in math. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're watching from and what time it is where you are. I want to know how far this story travels. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The green glow was first noticed during a total lunar eclipse. When the moon's reflection was smothered by Earth's shadow, cameras finally saw clearly. They could have looked anywhere. Andromeda, Orion, the cold veins of the Milky Way, but the lenses found Atlas. What they captured wasn't ordinary reflected sunlight. It was self-emission, a radiance from within the coma. A contradiction glowing 4.5 astronomical units away. In normal physics, green means diatomic carbon. C2 molecules split and rebonded under ultraviolet light. Comets do this all the time. Small chemical orchestras playing their predictable symphonies. But spectroscopy said otherwise. 3-eye atlas carries almost no C2, no carbon chains to sing that wavelength. And yet the sky itself insists it is green. So maybe you start listing possibilities like a detective in an impossible case. Fluorescence from CO2? No, that emits in the infrared. Sodium? Wrong spectrum. Ionized nickel? That requires heat the object doesn't have. Aliens? Too easy, and too lazy. But in that pause between laughter and unease, a thought flickers. What if this is not chemistry as we know it, but chemistry older than the sun? What if these reactions began in another system entirely? A kind of stellar memory, carried here like dust on the wind. Astronomers in Chile and Hawaii tried to replicate the signal, cross-checking their instruments against calibration lamps, background light, cosmic rays. Every control returned the same truth. The color persisted. The green remained, even when everything else was explained away. It's strange how color can feel like consciousness. The ancients saw green as the hue of renewal, of life breaking through stone. Here, under your telescope lamp, it's the color of uncertainty. It doesn't shout. It just refuses to disappear. You think of other nights when humanity mistook reflection for meaning, when Venus became a goddess, Mars a god of war, and every flicker in the heavens carried intent. We've come far since then. Radio telescopes, spectrometers, radiometric decay curves, and yet the impulse remains. We name the unknown to quiet our fear. The name Atlas itself carries irony. The robotic survey that found it, the Asteroid Terrestrial Impact Last Alert System, was built to warn us, to catch the stones that could end us. But instead of doom, it found a messenger, something that seems to whisper, "You're being watched," but kindly. You remind yourself, this isn't superstition. This is data. Spectral flux at 518 nanometers, apparent magnitude 15.6, velocity vector nearly constant relative to the heliocentric frame. Numbers don't lie, but they also don't comfort. The desert wind presses against the dome of the observatory. Sand hisses softly across the metal tracks, a reminder that everything erodes. Mountains, instruments, civilizations. Only curiosity resists. That and the faint hum of machinery measuring the infinite. You log another observation. No visible outgassing jets, but an increasing coma radius. 20 kilometers now, shimmering faintly like breath on glass. The brightness curve oscillates gently, irregular but rhythmic. It feels alive in the way all steady things do. Maybe you remember the Voyager probes, still whispering their telemetry across the dark, or the Pioneer plaque, with its naive engraving of humans waving into the void. We've been sending messages for half a century hoping someone will notice, and now, perhaps, something has. Still, you remain cautious. In science, wonder is permitted. Conclusions are not. You make a note. Luminosity likely non-cometary. Pending verification. That's how faith looks in a lab notebook. Uncertain, yet precise. Out here, green isn't just a color, it's a question. What makes an object shine against reason? What makes a mind stay awake when it should sleep? And what do both questions have in common? You close your eyes, seeing the afterimage of that emerald light lingering on your retinas. It pulses, steady, distant, ancient. Somewhere between a heartbeat and a signal. Scientists still argue whether 3I Atlas is natural or engineered, whether the universe is playing tricks or revealing patterns. But for tonight, under this endless ceiling of stars, it doesn't matter. The mystery is enough. The glow is enough. Because sometimes the cosmos doesn't ask to be solved. It asks to be witnessed. The name came before the understanding. That's often how it goes in astronomy. We label the unknown first, hoping the act of naming will give it shape. 3I Atlas. A code at first, 3I, for the third interstellar object ever recorded by humankind. Atlas, the automated watchman that found it. But even codes become metaphors over time. You whisper it once more into the darkness. Atlas, the titan who held the sky on his shoulders. The myth breathes beneath the mathematics. Maybe that's fitting. A sentinel carrying the weight of our curiosity. When the first interstellar visitor, Oumuamua, slipped past us in 2017, the name was Hawaiian. The scout, the messenger. We name these things with reverence, as if language itself could anchor them against the void. Perhaps that's all we can do, mark their passing so that we feel a little less transient ourselves. You imagine the chain of people who brought this object into consciousness. The early morning technician adjusting calibration lenses, the graduate student staring at pixelated streaks, the astronomer cross-checking orbital residuals until a number refused to fit. Somewhere, a line of code blinked anomaly detected, and humanity gained a new neighbor. A simple definition. Interstellar means born elsewhere. Not of our sun, not caught by its gravity. A thing that wandered billions of years across the galactic medium, past nebulae and magnetized dust and the wreckage of stars, to arrive here briefly, uninvited but not unwelcome. You write that down too, not unwelcome. The stars don't care about hospitality, but humans do. We greet even comets like guests. It's a reflex, an echo of the old seafarers who named every storm they feared. When the robotic system Atlas spotted it on July 1st, 2025, it was just a moving pixel against static. The software predicted impact trajectories, as it was designed to do. None intersected Earth. So the alert system lowered its guard, but curiosity did not. The object was different, hyperbolic, moving at escape velocity from beyond the sun's reach, tilted oddly against the ecliptic. From the beginning, there was poetry in the data. Eccentricity greater than 1.0, a number that means it will never return. Inclination equals 59 degrees, as though it's entering at an angle no planet could follow. Velocity equals 67 kilometers per second, fast enough to outrun history itself. You realize how absurdly fragile knowledge is. We record these measurements on spinning drives smaller than your hand, and yet we expect them to outlast civilizations. At the observatory, someone jokes that the name 3I fits because the object sees us before we see it, the way predators do. The laughter is tired,
Patience
a coping
may be the
mechanism.
universe's language
The
of
real
intent.
three eyes, of course, are the trio of telescopes that confirmed its detection: Haleakala,
Patience may be
Mauna
the
Kea, and
universe's
Palomar.
language of intent.
3 pupils gazing outward, triangulating the trajectory of a thought. There's a quiet competition in astronomy. Who gets to define discovery? Each institution wants to pin the flag of data first, but no one can own an interstellar visitor. It belongs to time itself. You think of the Atlas myth again. The Titan punished to carry the heavens forever, unmoving. How different this new Atlas is, free, unburdened, gliding between worlds while we stand still, staring upward. Maybe that's the real inversion of the myth. The sky now carries us. Names, trajectories, orbits. They're all human inventions to hold on to something that refuses to be held. But in a deeper sense, naming is confession. It says, I have seen you. I want you to know that I know. There's an old superstition among sailors that naming a thing gives it power. In science, it gives it meaning. The name becomes a bridge between ignorance and wonder. You write the catalog entry in your notebook, but your handwriting drifts into metaphor again. 3-eye Atlas, a fragment of the thick disk memory, a shard of time older than our sun. Because that's the other truth. Spectroscopic analysis suggests that 3-eye Atlas originated from the thick disk of our galaxy, a realm of ancient stars formed 7 billion years ago. If you were to personify it, the object is not young, not curious, not reckless. It is elder, a relic carrying the chemistry of an age before Earth even cooled. You picture it now, a silent traveler shaped by pressures beyond comprehension, crossing interstellar frost, absorbing radiation older than language. Its surface may hold isotopes whose half-lives outlast continents. Each atom could tell a story of another star's death. Scientists still argue whether such objects are common or cosmic accidents. Some propose that every planetary system ejects debris into the dark, fragments of birth and collapse endlessly trading places. Others insist it's rare, a 1 in a billion coincidence that we even noticed. Both theories feel comforting in their own way. One says we are part of a great circulation. The other says we witnessed something miraculous. You take another breath. The air smells faintly of ozone and metal, the scent of electronics and night dew. The telescope tracks automatically now, its motors whispering in subsonic rhythm. Somewhere inside the hum, you imagine the heartbeat of Atlas itself. There's an elegance in the phrase third interstellar object. It sounds bureaucratic, but it hides awe. As if the cosmos keeps a census and we've just updated the ledger. 1-eye, 2-eye, 3-eye. The beginnings of a lineage, the slow alphabet of infinity. And beneath it all, an unspoken realization. We are not the center. We never were. Objects pass through, indifferent to our astonishment. But still, we name them, to remind ourselves that seeing is not ownership, it is participation. You whisper the name once more, 3-eye Atlas. It feels less like a code now, more like a prayer. The coma comes before the understanding. You've seen comets before, bright smudges with tails like thoughts unraveling in the dark. But 3-eye Atlas isn't one of them. Not exactly. Its halo, that glowing cocoon of gas and dust, behaves like a comet's should. Yet, beneath every spectral line, something disobeys expectation. When the first high-resolution data arrived from the European Southern Observatory, the numbers looked wrong. The coma contained almost no H2O, no icy sublimation of water vapor, the signature breath of ordinary comets. Instead, instruments recorded thick bands of CO2 and a trace of something metallic, something dense.
The silence itself
It shouldn't
is
be
data.
possible. At this distance from the sun, carbon dioxide should remain frozen. It doesn't vaporize
The
easily,
silence itself
not unless the nucleus
data.
hides strange chemistry or heat trapped by an unknown mechanism. You picture
silence
it, a
itself
worldlet of frozen
is
minerals
data.
warming itself in the emptiness, glowing softly like a coal that never quite dies. Scientists offered
silence
explanations.
itself is
Maybe the
data.
crust was darker, absorbing more solar radiation. Maybe radioactive decay in its core generated thermal stress. Maybe. The word scientists use when data refuses obedience. You trace the curve of its spectrum, a set of faint green spikes, like the heartbeat of a ghost. They say the coma extends nearly 20 kilometers across, a miniature atmosphere around a nucleus perhaps 10 or 11 kilometers wide. By cosmic standards, that's neither small nor large. But in meaning, it's immense. Every grain of dust in that halo was once bound to another star, sculpted by gravity that no longer exists. You realize that even the light reflecting off it tonight left hours ago. By the time it reaches your eyes, the configuration of gas may already have changed, meaning the atlas you observe is already a memory. That thought stays with you. Every observation is the study of what no longer is. A physicist once said that astronomy is archaeology without ground. You dig through time instead of soil. And 3I Atlas is a fossil mid-flight, a remnant of an alien dawn. Yet it glows.
Greetings
And the
from
glow
people of
confuses
Earth.
even
We are
seasoned
reaching out to the
astronomers.
stars.
Because in a normal comet, carbon chains like C2 and C3 are the source of emerald light. Ultraviolet photons from the sun strike these molecules, splitting them, exciting electrons, and releasing visible radiation around 518 nanometers. That's why many comets briefly turn green near perihelion, but when spectroscopy probed Atlas, there was no C2. None. So why does it shine in that same color? The simplest answer, we don't know. The more courageous answer, maybe something we haven't imagined yet. A few researchers from JPL proposed an alternative. Exotic hydrocarbons, long frozen under cosmic rays, could release unstable radicals under heating. Molecules never before cataloged in our system, a kind of chemical handwriting from another star. Another paper suggested photoluminescence, sunlight scattering off mineral dusts mixed with metallic compounds. Nickel again. Always nickel. As though the element had followed Atlas from creation, waiting for the right moment to announce itself. You pause at that thought. Nickel is not random. It's magnetic, conductive, resilient. The kind of metal civilizations use to build endurance. Rocket chambers, turbine blades, data cores, all alloyed
Perhaps
with nickel.
patience is the only
The
language
coincidence
the universe
is uncomfortably poetic. A fringe astronomer from Prague
Perhaps
murmured the
patience
heresy
is the only
aloud.
language
If
the
it were an
universe
engineered
respects.
object, this is exactly what you'd expect to see.
Perhaps patience
The room went
is the
silent.
only language
No one
the
answered.
universe respects.
The conversation shifted back to radiation curves and sublimation
Perhaps
constants.
patience is
That's
the
how
only
science
language the
protects
universe
itself,
respects.
by talking around the wound. Still, the question hangs there. What kind of natural body burns with such order? You remember Oumuamua's paradox, how it accelerated as though pushed by invisible thrusters yet bore no coma. Atlas seems to invert that riddle. It has a coma, but one that doesn't obey chemistry. Maybe the universe enjoys irony. You lean closer to the eyepiece. The coma shimmers, faint and uneven, like breath against glass. It expands slowly, releasing tendrils of light that twist before fading. You imagine the sound it would make if space allowed it, the sigh of gas escaping rock, the exhale of something ancient remembering warmth. Data logs show minor fluctuations. The coma's brightness oscillates every 7 hours, echoing the tumbling rotation of the core. The rhythm is hypnotic, steady, patient. You could fall asleep counting its flickers. And maybe that's the danger of studying things so far away. The numbers lull you into metaphysics. You stop asking what and begin asking why. Why does a comet from another star choose to glow in a color our eyes find beautiful? Why does the absence of expected molecules feel like meaning? You think of old myths again. In Greek tales, a green light often signified rebirth. Persephone rising from darkness, vegetation returning to earth. Perhaps it's coincidence, perhaps resonance, but the brain insists on story. You're a human being. You read the cosmos the way others read scripture. So you let the thought settle. Maybe the color isn't a message. Maybe it's a mirror. A reflection of our instinct to find purpose in persistence. The data continues to arrive. Each night adds more points to the chart, but the curve doesn't converge. It diverges beautifully. The more precisely we measure, the less we understand. And you wonder, if one day the instruments fail and all we have left is memory, will the mystery feel smaller or larger? Somewhere at this very moment, the green glow still burns against the infinite black, unwitnessed. No telescope, no observer, just the physics of isolation performing itself. Scientists still argue whether Atlas's coma is chemical, mechanical, or something between. The debate will last decades. Maybe that's the point. Because sometimes the cosmos gives us puzzles not to solve, but to sustain us, to keep curiosity alive when certainty has gone cold. And out there, in that endless silence, a green question keeps expanding. Nickel shouldn't shimmer in the dark. Not out here. Not now. And yet, when you open the latest spectrographic readouts from the Chilean desert, there it is. Bright emission lines of nickel vapor, thin and deliberate as threads of handwriting across the sky. You stare at the chart. Nickel requires heat. To turn solid metal into gas, you'd need thousands of degrees. A furnace, a flare, a star. But 3I Atlas is still far from the sun, adrift between Mars and Jupiter, where even sunlight feels old. The thermodynamic models say it should be cold enough to freeze carbon dioxide solid, cold enough to still the dance of every atom. And yet it's bleeding metal into the void. Someone proposes micrometeoroid impacts, tiny collisions releasing localized heat. Someone else blames cosmic rays. The truth is that every explanation feels like an apology, because if it's not heat, then what is it? The paper from the Namibian observation team puts it plainly. Detected Ni emission intensity inconsistent with heliocentric distance, mechanism unknown. Inconsistent, unknown, words that both comfort and unsettle. They remind you that mystery is not failure. It's a sign of the frontier. You lean back in your chair and imagine the nucleus of Atlas rotating, slow and solemn, shedding filaments of dust laced with metallic atoms. Each rotation takes hours, and every 7-hour cycle, the green light pulses faintly, as if synced to an invisible rhythm. The metals disperse, ionized by the sun, scattering trails of light invisible to the naked eye, but radiant to machines that dream in data. You think of early alchemists staring into crucibles, believing metal held the secret to transformation. They were wrong about the formulas, but right about the longing, the desire to turn base matter into revelation. And now, centuries later, we find ourselves doing the same, gazing into spectrograms instead of flames, searching for the gold hidden inside uncertainty. Nickel, CO2, no water, no carbon chains. It's like a recipe missing the ingredient of life, but there's another pattern. Whenever something in space behaves too strangely, there's always one word that slithers into the conversation. Artificial. Not shouted, never confirmed, but whispered. Quietly enough to pretend you didn't say it. The logic goes like this. Nickel-based alloys are ideal for high-temperature engineering. Engine chambers, thrusters, hull reinforcements. CO2 exhaust is a byproduct of combustion. The absence of random acceleration implies controlled stability. The symmetry feels designed. Of course, you remind yourself, nature designs too. It just takes longer. At a seminar in Pasadena, a young researcher stands and half jokes, "If it's a ship, at least it's polite." The laughter is hesitant but genuine. Humor, that fragile shield against the impossible. No one in the room truly believes 3I Atlas is a spacecraft. But no one can fully rule it out either. The data doesn't laugh back. Still, the mystery refuses to shrink. You scroll through archival records of other metallic comets. Ikea Seki, C2006P1, McNaught, C2012 S1 Ison, all known to release traces of iron, magnesium, even sodium, when near perihelion, but none this far out, none this cold, and none glowing green while lacking carbon chains. You jot a note in the margin of your notebook. The chemistry behaves like intention. That's not science, it's confession. You think of the Voyager plaque again, the golden record with its pulse of hydrogen, the map of our system drawn like a child's crayon. We sent metal into the void as proof we were here. Now, perhaps the void has sent metal back. But there's also something deeply human in that. This desire for echo, for confirmation that we're not alone in wanting to understand. A poet once wrote that nickel remembers heat even after the fire forgets. Maybe Atlas remembers something too. The star that made it, the catastrophe that threw it loose, the silence that followed. You imagine its birth, a collision billions of years ago, two proto-worlds slamming together, their crusts boiling, cores exposed. The fragments hurled outward, some swallowed by gravity, one flung free into galactic exile. Over eons, radiation fused its minerals into mirror-like alloys, its crust layered with frozen gases, its scars sealed by distance. And now it passes through our system like an old traveler, leaving a faint trace of itself behind. Vaporized nickel, glowing green, defying cold. Maybe that's all it is. A survivor of an ancient accident. But survival, in any form, carries story. Scientists still argue whether Atlas's metallic emissions can be modeled with natural physics alone. Some claim it's simple thermodynamics, others suspect deeper anomalies. The debates grow gentle over time, less about proof, more about meaning. Because deep down, everyone studying it feels the same quiet unease. This object behaves as if it knows restraint. It emits just enough to be seen, but not enough to explain itself. And that makes you think of people, how we reveal only fragments, hoping others will infer the rest. How we hold back what matters most, not out of malice, but to remain mysterious, and therefore alive. You realize that in some way, 3i Atlas is doing the same thing. It's not hiding from us. It's teaching us how to look longer, slower, more humbly. The universe doesn't owe us clarity, it owes us wonder. And so you stare again at that improbable nickel line on your screen, bright as a signature, calm as a heartbeat. Somewhere far beyond sight, an object spins, not quickly, not nervously, but with the patience of something that has seen stars die and be born again. And for one quiet moment, you feel its calmness enter you too. You've seen motion before, planets glide, comets spin, asteroids tumble, but not like this, 3. I-Atlas moves as though the universe itself were holding its breath. Its path is clean, unwavering, elegant in a way that mathematics rarely is. The telemetry confirms it. For 5 months, from first detection in May until October, its velocity and trajectory have remained almost perfectly stable. No sudden bursts of acceleration, no unaccounted drift, just a line, unwavering, threading through space like a thought that refuses to falter. At first glance, that doesn't sound strange. A rock moving predictably. Isn't that what rocks do? But comets aren't rocks. They're leaky, messy, impulsive. When they approach the sun, they boil, venting gas and dust that push them off course. It's called non-gravitational acceleration, or NGA. It's what makes every comet dance. Atlas doesn't dance. Each day, its trajectory shifts by less than 1.5 kilometers, a whisper compared to the 100-kilometer daily variations of 2I Borisov, or the 1,000-kilometer swings of Oumuamua. By cosmic standards, that's unnatural stillness. If this were a laboratory, you'd say the system is damped. If this were art, you'd call it composed. A researcher at Caltech once described it this way: Atlas behaves like it's aware of its own movement. The remark drew polite laughter, then silence. Awareness isn't a term physics uses lightly, but maybe it should. Because precision like this implies balance, equal forces, symmetrical release, or a hidden mechanism compensating for every disturbance. Nature can do that, but rarely with such restraint. You picture the object coasting through interplanetary space, the sunlight spreading over its surface unevenly, yet somehow never unbalancing it. A slow tumble every 7 hours, but no net change in thrust, like a dancer spinning endlessly without ever stepping out of rhythm. It makes you think about intent, how humans recognize pattern as personality. If a candle flickers, we call it wind. If it flickers twice in rhythm, we start to listen for code. That's what data does to us. It tempts belief. Some argue that the steadiness proves Atlas is simply massive, a 20-kilometer core resisting small forces. Others note that even larger comets like Hale-Bopp still jittered 10 times more. There's something else at play here, something beneath the math. Maybe the object is venting gas evenly from all sides, like an unconscious act of symmetry. Maybe its mass distribution cancels torque. Maybe, that word again. In science, maybe is both humility and hope. You trace the orbital plots again. Heliocentric coordinates scrolling across your monitor. Each dot is a moment in time, each segment a chapter of motion. The curved threads past Mars, dips inward toward Venus, then slings toward Jupiter. It's a long arc of precision. If Atlas were a pilot, this would be perfect navigation, but rocks don't navigate. A few late-night theorists whisper about course correction, about tiny adjustments invisible to spectrographs. No evidence supports it, and yet the imagination lingers. After all, the object's stability itself is the evidence. It doesn't need to change course. It already knows where it's going. And you, watching from your observatory, realize that this calm, deliberate motion mirrors something human. The way purpose feels when panic subsides. The trajectory of conviction. Because motion, when too stable, stops looking like drift and starts looking like decision. You think back to Oumuamua's erratic spin, how it tumbled end over end, how its acceleration betrayed unseen thrust. That one was wild, chaotic, unpredictable, playful even. Atlas, by contrast, is serenity embodied. The difference feels almost philosophical. If Oumuamua was a question shouted into the dark, Atlas is the silence that follows, waiting to see if we answer. The simulation model runs again on your screen, bright dots tracing orbital paths against the backdrop of the solar system. Mars glows red, Jupiter blue, the sun a molten sphere at the center. Atlas cuts through them all like a straight line through a web. You remember a colleague's joke: if it's artificial, it's on autopilot. If it's natural, it's meditating. You prefer the second answer, meditation. That's what this motion feels like. Not urgency, not escape, just continuity. The persistence of existence without explanation. Every measurement reaffirms the same numbers, semi-major axis undefined. Eccentricity, greater than 1. Inclination, steady. Acceleration, negligible. It's the definition of equilibrium, and yet equilibrium is never permanent. You wonder when the stillness will break. The sun will test it soon. As Atlas draws closer, sublimation should surge, gases should erupt, velocity should shift. Maybe then, finally, the object will behave like the comet it's supposed to be. Or maybe it will keep gliding, unchanged, the way truth sometimes glides past belief. You catch yourself staring at the graph too long. The lines blur into green and black, data turning to art. It's easy to forget that behind every number is light, and behind every light is time, and behind every time is silence. Scientists still argue whether 3I Atlas's path is purely gravitational or something more. Some call it coincidence, others call it symmetry, and a few, in hushed tones, call it intention. But no matter the explanation, one thing is clear. This object moves through the solar system the way a thought moves through the human mind. Invisible, exact, unhurried, unstoppable. And as you watch its coordinates drift across your screen, you realize that maybe the most extraordinary thing about Atlas isn't what it's made of or where it came from, but how perfectly it refuses to lose its way. You remember the first 2 visitors. They arrived before 3I Atlas. and their names still echo like prelude movements in a cosmic symphony. Oumuamua and Borisov. Both were once mysteries, now they are memories, faint data trails archived in the databases of human curiosity. Oumuamua came first in 2017, a shard of something long lost moving at 87 kilometers per second, too fast for the sun to hold, too strange to classify. No coma, no tail, no visible outgassing, and yet it accelerated as if something inside it breathed. That small, irregular flicker of velocity broke Newton's calm and cracked open speculation. Radiation pressure? Hydrogen jets? Or something we didn't have words for yet. Then 2I Borisov followed, 2 years later. A comet, this time familiar, comfortingly ordinary. It came in glowing, shedding ice, spinning through sunlight, behaving just as textbooks promised. It restored the balance, reminded us that the universe still obeyed itself. After Oumuamua's enigma, Borisov was the sigh of relief that science needed. And now, Atlas, third in the line, but nothing like the others. Where Oumuamua was invisible and Borisov was predictable, Atlas seems sentient in its stillness. You lean over your desk and imagine them as chapters in a story the galaxy is telling us. First, a scout, Oumuamua, silent and fast. Then, a messenger, Borisov, friendly, obvious, transparent. Now, the watcher, Atlas, slow, deliberate, inscrutable. It's tempting to believe in sequence, in pattern. The mind craves it. 3 is the smallest number required for rhythm. Setup, confirmation, transformation. Nature, it seems, writes in 3s, but science resists narrative. So you restrain yourself and return to the data. All 3 visitors traveled on hyperbolic trajectories, each one bound for the stars. None belong here. That's the most humbling fact. The solar system isn't a destination, just a waypoint. Our home, to them, is a brief intersection of gravitational geometry. Still, you can't help noticing what feels like choreography. Oumuamua came almost head-on from the direction of Vega. Borisov followed roughly the same route through Cassiopeia, and Atlas now approaches from the side, the cosmic equivalent of a crosswise glance. 3 lines meeting not at a point, but within the same celestial decade. Coincidence, perhaps, or communication through alignment. In academic journals, you'll find no poetry, only equations. Eccentricity greater than 1. Heliocentric velocity constant, radiometric albedo low. But you, alone under the observatory dome, see the continuity, how each visitor tested a different part of our perception. Oumuamua challenged dynamics. Borisov confirmed chemistry. Atlas confronts comprehension itself. Someone once joked that these are the universe's introductory lessons. Lesson 1. You don't know what a rock is. Lesson 2. You don't know what a comet is. Lesson 3. You don't know what intelligence means. You smile at the thought, not because it's true, but because humility always begins in laughter. Out the window, the night is thin, silvered with starlight. Every photon landing on your retina has traveled for centuries, and yet it feels immediate, intimate. You think of Galileo squinting through polished glass, sketching moons without knowing he was sketching time itself. You think of Carl Sagan, whose voice first taught the public that science could sound like poetry. Science, after all, is humanity's longest conversation with itself. So what are we saying now to ourselves through Atlas? Perhaps that not every anomaly is a threat. Perhaps that the universe in its vast indifference still makes room for elegance. Oumuamua, Borisov, Atlas. 3 punctuation marks at the edge of human understanding. The first was a question mark, the second a comma, the third maybe a pause before the next sentence. There's a strange comfort in that rhythm, in realizing that we are not the authors, merely readers deciphering a language written in ice and metal and motion. The astrophysicists still debate in conferences and papers how many such objects drift unseen between the stars. Some
data is
models
too clean
suggest
for a
1 per
natural event.
cubic
The
parsec,
data confirms the
others say
gravitational lensing
trillions.
effect.
But
It has
even
to
if
be
they're
gravity,
countless,
or a
most will
localized
pass
manipulation of
unrecorded.
space-time.
Too
We can't
dim,
rule out control
too
yet.
fast,
It's clearly
too quiet.
gravitational influence.
Our instruments catch
I
only
maintain
those
it's
that
a
want to be
controlled
caught.
shift.
And
The
perhaps
patterns are
that's
too
what makes
precise for
these three
nature.
so haunting. They chose visibility. You jot another line in your notebook. Maybe the universe reveals itself in degrees of mercy. Not revelation, but allowance. In quiet moments, you think about the people who will find this data 100 years from now. They'll scroll through spectral plots and orbital diagrams, long after you're gone, trying to interpret what you once felt instead of proved. Maybe they'll call this era the first era of interstellar visitors. Or maybe it will just be a footnote. The humans noticed 3. You look back at the telescope readout. Atlas remains steady, its faint coma glimmering like a wound stitched with light. The other 2 have long since vanished, gone back into the dark, their mysteries dissolved into probability. And yet somehow, the story feels unfinished, as if the cosmos itself has taken a breath and hasn't exhaled yet. Scientists still argue whether these 3 arrivals share origin or accident, but no one denies the feeling, that sense of sequence, of escalation. It's almost enough to make you believe that discovery, like art, comes in movements. And if that's true, then Atlas isn't just the 3rd visitor, it's the overture to something larger. Between gravity and choice, there's a narrow corridor where mystery lives. 3, I-Atlas floats in that space. Not bound, not free, neither random nor ruled. It follows the curve of physics so precisely that it almost looks deliberate. When you plot its orbit in simulation, you see the same truth repeated. The math fits perfectly, yet meaning leaks through the edges. You're reminded that equations describe how, never why. Gravity, after all, is a kind of obedience, but Atlas behaves like something that remembers freedom. The data says its trajectory is gravitational, hyperbolic, sun-bound only in passing. Yet the absence of visible non-gravitational acceleration doesn't mean absence of control. Perhaps it is simply steering better than we can detect. The instruments register nothing beyond the faint exhale of CO2 and nickel dust. And still, it never drifts. You ask yourself quietly, is intention a measurable quantity? If a pebble rolls downhill, physics explains it. If a spacecraft does, intent guides it. If a comet acts like both, what language do we use then? Maybe agency is too heavy a word for matter, but maybe we are too cautious with wonder. Philosophers once debated whether falling apples choose to fall, whether will pervades nature itself. Newton silenced them with calculus, and we mistook that silence for truth. But Atlas resurrects the question, quietly, elegantly. What if motion can contain awareness, not of mind, but of pattern? The universe recognizing itself through balance? You remember reading about the Voyager attitude control system, those tiny hydrazine thrusters that have kept the probes oriented for almost half a century. They fire in bursts measured in milliseconds. Invisible corrections holding the antennas to Earth. Without those adjustments, Voyager would drift into meaningless spin. Atlas moves with similar grace, though without evidence of thrusters, without even the courtesy of explanation. Some scientists call that stability statistical anomaly. Others call it perfect coincidence. You, sitting beneath the slow rotation of the observatory dome, call it poise. Maybe that's what separates chaos from intelligence, not noise, but rhythm. The irony is that humans too exhibit non-gravitational acceleration. Impulse, fear, curiosity, love, forces that deflect us from the orbits we were born into. Atlas, meanwhile, seems content with precision. It doesn't hurry. It doesn't rebel. It simply is. You find yourself whispering its coordinates aloud like prayer. Right ascension 18 hours, declination minus 21 degrees, inclination 59 degrees, velocity 67 kilometers per second. Numbers that sound like psalms. If belief is pattern recognition applied to mystery, then astronomy is faith through measurement. There's a small group of theorists who treat these interstellar visitors not as accidents, but as part of galactic dynamics. The Great Exchange, they call it. Every solar system ejects a few fragments into interstellar space during formation. Over billions of years, those fragments wander, collide, and occasionally pass through another system. Planetary diaspora. Rocks as diplomats. You love that phrase. It makes the coldness of the cosmos feel almost kind. If Atlas were simply such a fragment, an ambassador of randomness, its motion would still hold beauty. But if it's something more, if there's even a whisper of guidance in its steadiness, then the implications stretch beyond science. It would mean that intention isn't confined to biology, that perhaps the universe can dream in trajectories. You think of how humans design spacecraft, precise, efficient, silent. Maybe that's the point. The more advanced a traveler becomes, the less it needs to announce itself. Noise fades with mastery. Atlas makes no noise. Every comet flares and fades. Every asteroid reflects unevenly. But this object radiates a calm luminosity. Its brightness curves a soft wave rather than a scream. That restraint feels civilized. It reminds you of the Japanese concept ma, the beauty of what is left unsaid. You turn the word over in your mind. Maybe Atlas is the ma of the galaxy. The pause between actions, the breath before revelation. Of course, this is heresy to astrophysics. But at midnight, heresy and hypothesis sound alike. The telescope tracks automatically now, its servo motors murmuring as the stars drift overhead. You sip coffee gone cold and imagine what kind of intelligence, if any, would send such an object. Not a scout, too subtle. Not a weapon, too quiet. Perhaps a mirror, sent not to watch us, but to see whether we're watching back. There's humility in that thought. To imagine that the cosmos, too, might be seeking company. Scientists still argue whether non-gravitational acceleration defines consciousness in mechanics. The debate is absurd, of course. Stones don't think, equations don't pray. But as you gaze at the plotted arc of Atlas, you feel a tug between knowing and believing. Maybe agency isn't something matter gains. Maybe it's something matter remembers. Gravity pulls everything towards simplicity. Choice complicates it. Atlas' balance between both embodies serenity. And perhaps in studying it, we are trying to learn serenity ourselves. To move through uncertainty without deviation, to orbit truth without needing to possess it. So you keep watching. The trajectory holds, the data steadies, and somewhere between gravity and choice, something, or someone, continues to move perfectly, endlessly, as if it already knows the way home. Light, when it travels far enough, becomes language. You don't just see it, you read it. Every photon carries syntax coded in wavelength and reflection. When you observe 3I Atlas, what you're really watching is a kind of silent communication, the cosmos speaking in spectroscopy. At first, astronomers measured only brightness, a simple pulse on a black background. But when they split that light through a prism, something deeper emerged. A spectrum so pure, so symmetrical that it felt almost deliberate. High albedo, unusually reflective for an interstellar body. Its coma gleams brighter than it should. The surface isn't dull rock or porous ice. It's polished. You stare at the graphs. Narrow lines, clean peaks, minimal noise. There's beauty in that precision, a geometry of certainty surrounded by infinite doubt. And you think, if light is a mirror, then Atlas reflects more than sunlight. It reflects attention.
If we're wrong,
The ancients
we
called
learn.
bright wanderers mirrors of the
right,
gods.
we risk
To them,
believing too
reflection
soon.
meant consciousness. A
If we're
star
wrong,
that glittered with
we
intention
learn.
was alive.
If we're right,
One that dimmed
we
was
risk
grieving.
believing too soon.
Modern science stripped away the
If we're
mythology,
wrong,
but not the
we
awe.
learn.
We still look at
If we're
brightness
right,
and infer meaning.
risk
We can't help
believing
it.
too soon.
You wonder what the object's surface must be
If
like.
we're wrong,
Smooth sheets
we
of
learn.
nitrogen ice, maybe,
If
or
we're
metal
right,
silicate crystal lattices
risk
fused by
believing too
radiation
soon.
pressure. Or perhaps something stranger, a thin reflective layer like foil, formed by eons of cosmic abrasion. Thin enough to catch light, thick enough to endure the journey. It's albedo, a measure of how much light it reflects, is nearly double that of typical comets. Not blinding, but suspiciously elegant, like something designed not to dazzle but to be seen. And that thought won't leave you, because in deep space, reflection is never an accident. When Voyager's cameras turned back toward Earth and captured the pale blue dot, it wasn't light leaving us. It was light returning. The reflection was an acknowledgement. You exist. Now, centuries later, another mirror drifts toward us, but this time we're the observers. And maybe somewhere, something else is watching the light we reflect back. A photon leaves the sun, strikes Atlas, and bounces home. 8 minutes to the sun, 7 hours to the telescope, an instant to your mind. In that brief loop, two civilizations might share awareness without ever meeting. You think of how mirrors are used in physics experiments. Interferometers, measuring distances smaller than atoms. Two beams of light split, travel different paths, and reunite. Their interference pattern reveals everything about the space between them. In a way, Atlas feels like the universe's own interferometer. One beam leaving, one returning, revealing the distance between knowing and wonder. You recall something from the philosopher Spinoza. Everything is a mode of reflection. He wasn't talking about optics, but the thought lingers. Reflection is participation. To reflect light is to exist in dialogue with the stars. So when you see that green shimmer from Atlas, you're witnessing a conversation older than language. But reflection too carries danger. Light hides nothing. If something wishes to remain unseen, it absorbs rather than reflects. So the brightness of Atlas, that serene willingness to be visible, is a kind of vulnerability. It reveals itself, knowing it will be interpreted. You imagine a being, ancient and patient, building a craft meant to wander eons. They wouldn't need communication arrays or blinking lights. They'd need only a surface that reflects curiosity, a mirror that rewards attention. That's what Atlas feels like. Not a signal, but an invitation. In some ways, all science is reflection. Humanity holding a mirror to the universe and discovering its own outline. What you see in Atlas says as much about you as it does about the object. You see precision and think intelligence. You see stillness and think grace. You see mystery and think purpose. And yet, perhaps that's what makes observation sacred, the fact that it always doubles back. The more you study its brightness curve, the more it resembles a pulse. Every 7 hours, the light dips and recovers, the rhythm of its rotation. The modulation is almost musical. If you sonify the data, convert light into sound, it becomes a soft oscillation, like breath. A luminous inhalation and exhalation of a thing that shouldn't breathe. You listen to that sound on your computer, looping it through a synthesizer, lowering the pitch until it becomes a heartbeat. The result is haunting, steady, distant, patient. You realize that for the first time you've heard Atlas, and though you know it's just data, it feels like voice. Scientists still argue about albedo anomalies. Some claim that high reflectivity results from cryogenic polishing, sublimated ices leaving a glassy crust. Others propose metal-rich coatings or layered silicates with refractive interference. But the argument doesn't matter tonight. What matters is the feeling of watching something shimmer without flinching, as if endurance itself could shine. You take one last look through the telescope. The light has softened now, faint from distance, yet the reflection persists. The night air hums, the universe waits, and you whisper, half to yourself, half to the stars. Not revelation, but reflection. Not communication, but recognition. Because in that moment, you understand. Atlas isn't showing us itself. It's showing us what we look like when we finally see clearly. December geometry. The phrase sounds poetic until you realize it's literal, a diagram drawn in the dark. As 3-eye Atlas threads toward the inner solar system, the alignment of planets becomes a kind of choreography. Mars first, then Venus, then Jupiter. Each world a silent observer along its path. Earth, for once, will not share the stage. will be hidden on the far side of the sun, watching only through reflections like an
designed, then why
audience
send it
peering
here?
into a mirror. In the observatories, the term is perihelion window, the brief moment when an object reaches its closest point to the sun. For Atlas, that happens mid-December. The orbital mechanics look simple, a hyperbolic curve skimming past the ecliptic, dipping within 28 million kilometers of Mars, 97 million of Venus, then bending outward again toward Jupiter. But geometry in space is never just distance, it's destiny, written in motion. The model on your screen shows thin lines weaving across a black void, the dance floor of gravity. The sun anchors the center, planets orbit in slow counterpoint, and Atlas approaches at an oblique angle, neither parallel nor perpendicular, but diagonal, the cosmic equivalent of walking into a room from a hidden door. If you exaggerate the scale, the whole system resembles an hourglass. Every orbit narrows toward the sun. Every trajectory bends around it. Time itself seems to flow through that luminous waste. You remember the earliest astronomers calling such alignments conjunctions of fate. They thought geometry carried intention, that proximity meant purpose. Now, centuries later, we still draw the same charts, only our ink is digital. As December nears, telescopes prepare like orchestras tuning before the overture. The James Webb Space Telescope will watch in infrared, measuring thermal signatures and chemical emission lines. The Hubble will observe invisible light, tracking surface brightness variations. Ground-based observatories in Hawaii, Chile, and Namibia coordinate photometric sequences, calibrating polarization filters so that every photon counts. It's more than observation, it's ritual. Humanity assembling its instruments to meet a visitor that may never return. Some nights you stand beneath the dome and imagine Atlas's point of view, looking inward at this fragile clockwork of worlds. From that distance, the sun isn't blinding, it's golden, almost tender. Mars glows faintly red, Venus a bright coin, Jupiter a marble streaked with storms, and Earth, hidden behind the light, is invisible. The only proof of our existence is the radio whisper of curiosity reaching outward. Maybe that's the geometry that really matters. Not the arcs of planets, but the lines of connection we draw across ignorance. In classrooms, students will soon study these numbers. Perihelion equals 1.8 astronomical units. Inclination equals 59 degrees. Eccentricity greater than 1. They'll memorize them without hearing the heartbeat beneath. They won't know that December 15th is not just a date, it's the point where trajectory meets transcendence, where physics and wonder briefly occupy the same coordinates. You zoom in on the simulation, tracing the orbit again. If you slow time to a crawl, you can almost hear it, a silent hum, the music of ellipses and hyperbolas crossing paths. Mars will be just behind Atlas as it passes, close enough that robotic orbiters might glimpse the halo. Imagine that, an artificial eye orbiting a natural mystery, both built from the same atoms of exploded stars. Scientists will publish papers, of course, spectral evolution during perihelion, albedo variation, and dust outflow rates. The language will be technical, precise, bloodless. Yet beneath every paragraph lies the same question whispered since the first comet streaked across a primitive sky. What does it mean that something from beyond comes so close, then leaves again? Maybe December isn't an ending, but a mirror of our own cycles. Approach, brightness, retreat. Every orbit tells that story, even the ones that never close. You remember a line from Kepler, written when he realized that planetary motion followed ellipses, not circles. The paths of the stars are the thoughts of God. Whether or not you believe in gods, you can feel the sentiment. Geometry as revelation, motion as language. And so, when you look at Atlas's plotted path, what you see isn't just math, it's meditation. The line curves not because it must, but because that's what beauty does when it meets gravity. It bends, it yields, it continues. Scientists still argue whether this geometry holds secrets, Gravitational assists, sublimation dynamics, orbital resonance. But in the quiet between datasets, you know the truth feels simpler. The universe isn't a machine of chaos or order. It's a pattern of patience. And in December, that pattern will pass behind the sun, unseen but not unfelt, like a thought you almost remember before it fades. It begins with a number, 1,420 megahertz, the frequency of neutral hydrogen, the most abundant atom in the universe. It is also, by coincidence or perhaps by design, the exact frequency of the most famous anomaly in the history of radio astronomy, the WOW signal. You've seen the original printout, a row of numbers, a spike of intensity, and one handwritten word in red pen, wow. It came from the direction of Sagittarius, a constellation filled with old stars and dust, the heartland of the galaxy. The signal lasted 72 seconds, narrowband, impossibly precise, never to return. That was 1977, long before Atlas. Now, almost 50 years later, the orbital reconstruction software draws a line backward through space and time, a curve extending beyond Neptune through the Kuiper Belt, out toward the dark edges of interstellar drift. And that line, impossibly, intersects Sagittarius, the same region, the same silence. Coincidence, maybe. The cosmos is full of them. But you can't help but feel the symmetry. A radio whisper from one century, a green glowing visitor from the next. Both faint, both fleeting, both arriving from the same celestial address. When you overlay the data, the image looks almost poetic. One signal made of light, another of motion, both converging through history. The universe, it seems, keeps clearing its throat as if to speak, then changes its mind. Astronomers call the 1420 megahertz line the water hole. It lies between the radio emissions of hydrogen and hydroxyl, the two ingredients that form water. In other words, between life's most basic building blocks. For decades, scientists imagined this as the ideal channel for interstellar communication, not because it's magical, but because it's universal. Any civilization with radio technology would know it, so if someone were sending a message, that's where they'd whisper. And now you're forced to ask, what are the odds that Atlas, a confirmed interstellar object, just happens to be moving from that same region? Most astrophysicists shrug. The galaxy is vast, they say. Sagittarius is statistically likely for random trajectories. But statistics has never been good at explaining timing. You picture the year 1977 again. Analog consoles, reels of magnetic tape, engineers half asleep beside humming machines. Somewhere in the static, a pulse of order arrives. A sound that shouldn't exist. They circle it, underline it, then file it away because no repetition ever came. The night ends. The data sleeps. And yet, maybe not everything that disappears is gone. If Atlas had been at the edge of the solar system, then, perhaps still inbound, perhaps already coasting inward, it would have been near the right position to emit such a signal. A coincidence too beautiful to ignore, too uncertain to confirm. Of course, correlation isn't causation. Maybe the signal was just natural. Plasma turbulence, cosmic ray interference, an unknown astrophysical burp. But even if that's true, it still says something profound about us, that we wanted it to mean more, that we saw a heartbeat where there was only noise. And perhaps that longing is the purest form of science. The refusal to let wonder die just because math hasn't caught up yet. You glance again at Atlas's coordinates. RA 18 hours, deck minus 25 degrees, drifting across Virgo now but still echoing Sagittarius in trajectory. The connection is fragile, but the human mind was built to connect. We trace patterns in clouds, constellations in stars, purpose in coincidence. It's how consciousness rehearses meaning. If the WOW signal was real, then December isn't just an orbital event. It's a reunion, a return. The echo of a question finally arriving to see whether we've learned how to answer. You imagine it, An object from another system, ancient, unhurried,
We listen
emitting a single
quietly,
pulse across
or
hydrogen's
not
frequency.
at all.
A message not of words but of recognition. We hear the same
We listen
silence you do.
quietly,
The
or
SETI
not at
researchers are
all.
cautious. They point antennas toward the sky, recalibrating for interference. Nothing yet. Only the soft hum of Earth itself, Wi-Fi, satellites, GPS, a chorus of technological self-reflection. Maybe that's fitting. Maybe we've become the noise we once listened through. Still, one team at the Green Bank Observatory will attempt a deep sky scan during Atlas's perihelion window. 50 terabytes of data for a single night. If they find nothing, the silence will be archived with all the others. If they find something, everything changes. You close your eyes and think of that number again, 1,420 megahertz. It's just a vibration, a wave oscillating 1.4 billion times per second. But to those who listen long enough, it feels like heartbeat speed. Scientists still argue whether the wow signal was natural, artificial, or simply misread. But maybe the truth doesn't lie in classification at all. Maybe it lies in continuity, in the idea that curiosity itself is a form of conversation. We asked a question once in 1977, and maybe, just maybe, December 2025 is the universe's way of answering, not in language, but in arrival. Silence has texture. You can feel it when you stand outside at 2 a.m., long after the city lights have folded into haze. It isn't absence, it's density. A field of unspoken frequencies pressing softly against your skin. That's what the scientists call the interstellar medium. Space between stars filled not with emptiness, but with quiet matter, hydrogen whispers, and magnetic drift. 3i Atlas moves through that silence like a syllable sliding across a sentence too large to read. We think of it as motion, but what if it's memory? What if every object that leaves a system carries the ghost of its origin, its heat, its dust, its chemistry, a kind of cosmic handwriting? Spectroscopy tells us that Atlas is rich in carbon dioxide, poor in water, heavy with nickel and iron. Its tail gleams faintly green, but not because of the molecules we expected. Something in its spectral lines defies the template, narrow, unusually consistent, almost engineered. When you compare it to 2e Borisov, the differences are unsettling. Borisov's scattered chaos, ice, dust, organic volatiles, a comet in every sense. But Atlas behaves like a disciplined traveler, shedding material evenly. Its non-gravitational acceleration practically nil. Comets wobble, Atlas glides. You picture the data plots, a calm, unwavering curve against the jitter of background noise. And you begin to wonder, is stillness the signature of something designed, or just the perfection of nature when unbothered by time? There's a line in physics that always sounded poetic to you. An object in motion remains in motion unless acted upon by an external force. Newton wasn't describing interstellar probes. He was describing loneliness, because out here forces are rare. To move for billions of years through the dark requires not power, but patience. Maybe that's what Atlas teaches, that endurance is its own propulsion. If you could stand upon its surface, a frozen cliff under a green haze, you'd hear nothing. No wind, no crack, just the hum of sunlight striking nitrogen ice, a vibration too slow for ears but real enough to measure. Temperature minus 240 degrees Celsius. Pressure practically zero. And yet the material persists, refusing to evaporate entirely, as if clinging to the idea of existence itself. Somewhere in a lab, a graduate student watches a simulation of that surface. They adjust albedo values, model sublimation rates, rerun the trajectory. The numbers hold, still stable, still improbable. They sip coffee, glance at the clock, and realize they are staring not at data, but at persistence. That's the paradox of science. The deeper you measure, the more you feel. The longer you stare, the less you're sure whether you're observing or worshiping. Scientists still argue whether Atlas's consistency is a clue. Some propose it's a super volatile body, with a balanced outgassing field, equal thrust in all directions, canceling its own movement. Others whisper cautiously that maybe it's hollow, its mass distributed in a way that resists gravitational perturbation. Hollow things, after all, ring differently when struck. You think of the Arecibo message, the human attempt to introduce ourselves to the galaxy. 1,679 bits of binary data encoded into a radio burst. It described our chemistry, our DNA, our location. We called it information. But maybe it was simply confession, a way of saying, we are here, we are trying. What if Atlas is another confession from someone older, subtler, quieter? Not a message in code, but in conduct. Motion without deviation, glow without noise, presence without aggression. It's easy to imagine intention in symmetry. It's harder to accept that the universe might just be beautifully organized by accident. Still, that's the edge we walk, the line between wonder and evidence. You remember how the Voyager 2 spacecraft, after 46 years, still sends back faint telemetry. Every ping a reminder that persistence doesn't always need purpose. Maybe Atlas is Voyager's reflection, not another civilization's envoy, but a mirror of what we ourselves have become. Patient explorers, wrapped in silence, propelled by curiosity. If you overlay both paths, Voyager leaving the sun, Atlas arriving, they almost meet, a few astronomical units apart, like two hands that nearly touch. It's tempting to imagine they recognize each other in passing. Sometimes the observatory's microphones pick up micro-tremors in the electronics, thermal pops, voltage size, the building itself settling against the night. You sit there listening, pretending each sound is a heartbeat from the stars. It's not, but the imagination is its own kind of data, so you keep listening. Because one day, when the last transmission comes through, a flicker in the noise, a frequency too deliberate to ignore, you'll want to be awake for it. For now, Atlas holds its course, unflinching, unhurried, and you realize we've spent decades asking whether we are alone, when maybe the better question is, what does alone mean to something that never stops moving? The silence hums again. You breathe. You wait. And somewhere, far beyond Mars, a green shimmer turns slightly toward the sun, not to speak, not to signal, but to remind us that even the quietest travelers leave echoes behind. By late November, the data shifts from measurement to meditation. The telescopes continue to record, of course, spectral scans, albedo curves, light decay rates. But you sense that even the scientists are beginning to whisper. 3I Atlas has become less an object of study and more a presence that moves through everyone's thoughts, like a recurring dream whose meaning hides behind its own simplicity. Each night, as the observatories turn their domes toward the southeast, the object grows brighter. Its coma, vast and diffuse, expands like breath in winter air. The tail, too, elongates, now stretching several million kilometers, but without the erratic turbulence expected from a comet of this scale. It's as though Atlas exhales in rhythm, not reaction. On paper, the explanation remains straightforward. Solar wind meets volatile surface. Sublimation creates outflow. Outflow creates pressure. But in practice, the math doesn't hold. The pressure is too low, the consistency too smooth. Something about it feels composed. A planetary scientist from Chile describes it best during a midnight interview. It behaves like it's reading the solar system, not reacting to it. That phrase lingers. We like to think of ourselves as the observers, the architects of instruments and equations. Yet as Atlas drifts past Mars, just 28 million kilometers away, it becomes impossible to ignore the reversal. For the first time, we feel observed. You picture the Mars Reconnaissance Orbiter, tiny against the scale of red desert and black sky, turning its camera outward to glimpse the green stranger sliding through the void. Perhaps Atlas's coma reflects the orbiter's faint signal, capturing our electronic heartbeat in a pulse of scattered light. For a second, the two worlds acknowledge each other across the silence. What if that's all communication ever is? Not language, not code, just mutual recognition. Astronomers model the orbit again. December 15th, perihelion, the moment of greatest proximity to the Sun. Afterward, Atlas will begin to fade, its glow softening as it moves outward past Venus, then Jupiter, then away. A trajectory that touches our neighborhood only once, a brief visitation in cosmic time. The question everyone keeps asking, will it survive its encounter with the Sun? Comets, especially those that skim close, often disintegrate. Heat fractures their nuclei. Sublimation hollows them into vapor. Yet the projections suggest Atlas might endure. Its structure, dense, metallic, cohesive, resists thermal disassembly. Even under 700 degrees Kelvin radiation, the core should hold. In the conference rooms, the language grows paradoxical. Degenerate resilience, controlled outgassing, non-chaotic vaporization. You realize they're describing faith in technical terms. If Atlas disintegrates, it will prove ordinary, an icy relic finally undone by proximity. If it survives, it will become myth. Either outcome changes the narrative. One confirms the limits of matter, the other hints at design. And as you scroll through the latest imagery, you notice something subtle. The coma isn't uniform. There's a region of intensified brightness offset from the nucleus, like a miniature aurora nested inside the halo. Polarimetry suggests it's not a reflection, but emission, polarized light consistent with ionized nickel vapor. Nickel again, always nickel. It's the element of endurance, used in alloys, spacecraft hulls, thermocouples. Here it appears not as trace impurity but dominant signature, as though the very structure of Atlas is engineered for thermal stability. The data feels less like coincidence and more like instruction. You remember an old term from astronomy's early days, wanderer with purpose. They used it for planets before understanding orbits. It feels apt again now. Because whatever Atlas is, comet, relic, or probe, it's teaching us something subtle. That movement can itself be intelligence, that persistence may be proof of thought. Back on Earth, public fascination grows. The media calls it the green messenger. Artists paint it as a cosmic eye, poets write about loneliness turned luminous. Children trace its path on digital sky maps. It becomes a mirror not of the heavens, but of hope. In the observatories, the tone is quieter. Scientists still argue whether it's a hyperbolic visitor or a fragment of something older. They trade papers, analyze uncertainties, and yet every discussion ends the same way. Someone pauses, looks out the window, and whispers, "It's still there." And maybe that's enough. In a world filled with impermanence, something steady feels divine. You imagine Atlas as it moves now, beyond Mars, between Venus and the Sun, glowing green against black infinity, unblinking, unchanged. Its trajectory a perfect balance between surrender and control. Physics calls it orbital mechanics. Philosophy calls it grace. The silence deepens. December draws closer. And as the telescopes track its slow approach, you realize that the mystery of 3I Atlas is not about what it is, but about what it does to us. How it makes even scientists sound like poets, how it turns equations into prayer. By the first week of December, the nights feel electric, not with sound, but with waiting. Every observatory on Earth points inward, toward the Sun, toward 3I Atlas, toward a question that no longer fits into science alone. You stand outside the control room, watching the faint shimmer of data scroll across monitors. The numbers are slow now, deliberate, like breathing. Temperature gradients, reflectivity ratios, angular momentum, all repeating, all stable. And yet, there's a rhythm beneath them that feels almost alive. No one says it out loud, but everyone feels it. We're witnessing something unrepeatable. The window of certainty is closing. By mid-December, Atlas will vanish behind the Sun, invisible for 2 weeks. A blind spot, a cosmic eclipse. When it reappears, it will already be outbound, fading fast. Whatever it truly is, we must decide what to believe before the light leaves us. Astronomers call this the inferior conjunction. Philosophers might call it faith. You open the observation log and trace the orbital curve again. The numbers are precise, unflinching. But when you tilt your head, the pattern looks like handwriting, a spiral looping inward before returning to the void. A message written not in ink, but in motion. "Do you think it's artificial?" someone asks quietly. You smile. "I think it's intentional." There's a difference. If it's a comet, then intention lies in physics. The patient choreography of mass and gravity, the inevitability of form. If it's a probe, then intention lies in mind, a geometry chosen, not inherited. Either way, Atlas is deliberate. Every kilometer of its trajectory feels chosen, balanced, precise. You begin to wonder if maybe deliberateness is what defines intelligence, not language, not tools, but the refusal to drift. The data agrees. No deviation, no random wobble, no erratic tail dispersion. It moves through the solar system like an artist tracing a single line through eternity, confident, uncorrected. At perihelion, December 15, 1422 UTC. Atlas will reach its minimum solar distance, 1.8 astronomical units, roughly 270 million kilometers. The models predict a surge of brightness as sunlight ionizes its coma. Magnitude 15, perhaps 14, still invisible to the naked eye, but within reach of every major telescope on Earth. And then a question hangs over the team. What if it changes course? Not a lot, just a fraction of a degree, a gentle curvature where none should exist. That's all it would take. 1 millimeter per second of non-gravitational acceleration, and the entire framework of natural would have to bend to accommodate it. The possibility turns silence into heartbeat. You remember Oumuamua 8 years before. The object that sped up when it should have slowed down. The one we never caught in time. Atlas feels like its echo. Not an accident, but a second chance. As the countdown to perihelion begins, a scientist from the JWST team whispers, "We only ever get one first time." Every other encounter is memory. You write that in your notes. It sounds like poetry disguised as data. Outside, the sun is rising, pale orange, heavy with winter haze. Somewhere beyond that glare, Atlas moves through radiance so bright it strips identity from matter. In that inferno, metals ionize, gases fracture. The coma shifts from green to white like the heart of a candle, and yet it holds together. Still no disintegration, still no chaos, still that quiet, deliberate motion. You imagine standing there beside it. No sound, no wind, only light folding around you like water, every atom trembling with purpose. You would see nothing beyond brightness. And then, perhaps, you'd understand that the sun isn't destroying Atlas. It's revealing it. Because that's what illumination does. It removes disguise. For years, we've treated observation as a form of control. To measure something is to define it. But Atlas refuses definition. It reflects everything we project onto it: fear, wonder, humility. It turns astronomy into introspection. When it emerges from behind the sun, it will either return unchanged, or it won't return at all. Both outcomes are sacred. If it breaks apart, we'll sift through the fragments, collecting dust older than our solar system, each particle a syllable of history. If it survives, we'll have to rewrite our definition of natural. Either way, knowledge expands. The universe keeps its promise, to surprise us just enough to make us remember how small we are. As the instruments hum and the sun crests the horizon, you whisper to no one in particular, "Not all visitors come to teach." Some come to remind us how to look, and maybe that's all three Atlas ever wanted. Not to be discovered, but to be witnessed. The countdown continues. December 15th approaches. In a few hours, light will bend, sensors will ignite, and the question will finally cross the sun. Whether it answers or remains silent no longer matters. The act of asking, That's the miracle. December 15th, the day the numbers finally meet the light. At 1422 UTC, 3I Atlas reaches perihelion, the closest point to the sun it will ever come, before the long fall back into darkness. The telescopes turn their mirrors to the edge of the star's corona, their sensors trembling with heat. Every second counts. You watch from the control room, eyes flickering between live telemetry and solar feed. The spectrum blooms, infrared, ultraviolet, hard visible. There it is, a faint emerald pulse against the blinding gold, the signature of Atlas burning through the glare like a thought that refuses to vanish. No tail disintegration, no deviation, just a rise in brightness. Magnitude 14.2. Then stabilization. The object endures. For 30 minutes the world listens. Radio dishes from Canberra to Madrid track the signal scatter, mapping the shape of its coma. The data resolves into a perfect ellipse, dense at the core, tapering with mathematical grace. Someone whispers, "It's alive." They mean the instruments, but you feel the word sink deeper. Thermal readings show a surface temperature approaching 700 Kelvin, hot enough to vaporize steel, yet the nickel signature strengthens instead of fading. Every rule of comet physics bends. The chemical ratios invert. Carbon dioxide dominates, water recedes, metals ionize and recombine like circuitry. It's as though Atlas is using the sun, harvesting energy, not fleeing from it. For a few moments, the images coming from the Solar Dynamics Observatory capture something indescribable. A halo forming a precise geometric arc, almost circular, almost deliberate, then dissolving again into gas. The data scientists call it a luminosity interference ring. The poets in the room call it a heartbeat. And then, silence. A glitch crosses the feed. Every telescope loses lock for exactly 47 seconds. When the signal returns, Atlas is still there, but its orientation has changed. The coma now trails away at a sharper angle, as if pivoted. The object's albedo drops slightly, its light more diffuse, less mirror, more mist. Someone recalculates the velocity. The numbers don't fit. A deviation of 0.06 meters per second. Nothing, yet everything. Too subtle for engines, too exact for chance. The room falls quiet. Every scientist knows the truth. This is the same pattern seen in Oumuamua in 2017. Not enough to prove anything, but too real to dismiss. The official term will be non-gravitational acceleration due to unknown mechanisms. Unofficially, it will be called the turn. You sit back, heart steady, breathing shallow. Somewhere beyond that blazing light, a piece of ancient matter, or ancient technology, just altered its future. It continues outward now, toward Jupiter, its path bending slightly sunward before curling back to the dark. That arc, if plotted, looks almost like handwriting again. One perfect stroke through the solar plane, a sentence ending with an ellipsis. Maybe that's what this was all along. Punctuation. A comma in the universe's speech. A pause between two thoughts too vast to comprehend. In the following hours, the data stream becomes surreal. The green glow begins to fade, replaced by faint traces of ultraviolet emission at 380 nanometers, the same wavelength used in high-efficiency optical sensors. It's as if Atlas is adjusting its spectrum, sliding out of visibility, choosing a different language of light. At 1710 UTC, the last optical confirmation arrives from Chile. The astronomer on duty writes a single note in the observation log: object luminous, trajectory stable, magnitude 16, drifting away. That's the end of the official record, but that night, while reviewing telemetry, you notice something in the radio data: a narrowband spike at 1420 MHz, hydrogen line frequency. Exactly the same as the WOW signal. It lasts 12 seconds, weaker but structured, amplitude rising and falling in harmonic sequence. Coincidence? Instrument noise? Reflection from the solar corona? Probably. But the timing, just after perihelion, feels too precise to ignore. You copy the segment, label it 12 to 15 to 25 signal A, and store it in a private folder. No one will believe you yet. They never do at first. Outside, night swallows the last glow of day. You step out of the observatory and look up. The sun has set. The air is cold. Somewhere behind that horizon, Atlas is receding. Quiet. Green fading to silver. Silver fading to nothing. You whisper the final observation to the dark. It came closer than any dream, and left quieter than any prayer. Tomorrow, the debates will begin. The papers, the arguments, the skepticism. But tonight, you let silence have the last word. Because what if that 12-second pulse wasn't a message? What if it was simply an acknowledgement? The universe whispering back, "We see you too." You wait for the afterglow, and the afterglow arrives like all honest endings do, quietly, without symbols. The screens dim, the graphs settle, and 3i Atlas becomes a thinner line on a larger map. Distance returns to its first profession, silence. What remains is not spectacle but residue, data sets, timestamps, the faint perfume of a hypothesis you can no longer prove and no longer want to let go of. You save the final nightly log and notice how the language has changed over these months. Fewer exclamation points, more commas. Commas are what you use when a thought needs room to breathe. The universe prefers commas. The object is outbound now, sliding toward the kingdom of cold, where sunlight becomes a belief rather than a weather report. Its albedo has fallen from mirror to mist. The green has softened to a whisper of ultraviolet. The spectroscopy is sparse, like thin handwriting under a lamp that's running out of oil. You keep reading anyway. Everyone does. We are readers of fading light. In the archives, you open a new folder. Atlas, post-perihelion. Inside, you drop what looks at first glance like detritus, calibration notes, filter offsets, stray hot pixels tagged and pardoned. But detritus is where meaning hides. Radiometric decay teaches that the most patient clocks are built from dying things. Science is the art of not throwing away the almosts. Here is what you know. The trajectory stayed hyperbolic. The non-gravitational acceleration revealed itself for 47 unimaginable seconds. The nickel lines declined, but did not vanish. CO2 still outweighed H2O. The geometry never forgot its grace. Here is what you don't know. Everything that matters to poets, and some of what matters to engineers. You step outside. It's late or early. The kind of hour when philosophers and maintenance crews share the same world. You try to see Atlas with your eyes alone and fail, which feels correct. The naked eye is a beautiful liar. Instruments are disciplined enough to tell the truth even when the truth is boring. Small joke 1. If boredom were evidence, half of cosmology would be Nobel eligible. A breeze climbs the hill. The air tastes like pennies and frost. You think of 1066, the year Halley's comet blazed into the Bayeux tapestry, a tiny stitched omen sewn by hands that never touched a telescope. A mainstream fact in a homespun medium. History has always recorded the sky with whatever thread it had. Tonight your thread is a terabyte funneling into a hard drive the size of a paperback. Inside, a student dozes at a terminal, cheek on forearm, code still running. You leave them sleeping. People who love the sky deserve gentle awakenings. You make tea strong enough to debug a planet and return to the console. The last residuals are in. The perihelion dataset has been re-reduced with stricter priors, mean residual 0.06 meters per second. Uncertainty stubborn as a mule. The figure caption writes itself and also refuses. The chats and preprints have begun to bloom. Sunlight-driven isotropic outgassing, field-aligned sputtering, porosity-regulated venting, thin film metallization, drag in the solar wind sheath. You add your own favorite euphemisms, the turn, the breath, the courtesy. Each is a small confession disguised as a term. Scientists still argue whether the signal spike at 1420 megahertz was instrument echo or intention, whether the 47 seconds were telemetry dropout or choreography. There are bright minds on each side, and the sides keep swapping. You underline a sentence from an old notebook, not revelation, but data. Not answers, but understanding. It has served you well. It also fails you now because tonight you want the luxury of revelation. There's a joke in the control room, small joke too. When the data disappoints, upgrade the adjectives. You resist the temptation. Adjectives can inflate wonder, but they also puncture it. On your phone, messages from people you love, a blurry photo of a sleeping dog, an invitation to breakfast in a diner that keeps the lights a little too bright, a reminder that the water bill still pertains to this universe. It is oddly calming to know that municipal utilities continue through cosmic events. Continuity is a kind of shelter. Small joke 3. If the cosmos ever sends an invoice, it will be itemized in neutrinos and due yesterday. You open the sound file again, the 12-second brush of hydrogen line radio from the night of perihelion, the maybe nothing that sounds like maybe something. You slow it until it becomes a tide. Then you slow it more, until it becomes what the heart hears when the mind is quiet. Hypotheses are not lullabies, but sometimes they sing. A quirky tidbit comes to mind, one you promised yourself you'd never use on camera, and yet, ancient Egyptians occasionally mixed crocodile dung into sunscreen. Questionable chemistry, admirable commitment. We have always put strange things between skin and star. Tonight you have placed mathematics between you and meaning, and it has shielded and warmed you in equal measure. You sketch a last diagram. Earth here, Sun here. Atlas already passed the line where language grows brittle. You draw a dotted curve beyond Jupiter, into a space where your pen judders because the desk is imperfect and also because the hand is honest. There is a region past which even metaphors frost over. You label it elsewhere and feel better. What will remain? The public will remember color. Students will remember the shape. The field will remember the anomaly. You will remember the hush after the hush, the thin ringing in the dome when the ventilators shut off and the night steps closer, just enough to feel like a hand on your shoulder. If a thing from another star could touch you, that would be the way. Not force, not fear, just weightless recognition. You close the log and send a final note to the team. Atlas stable, outbound, analysis ongoing, gratitude perpetual. You consider adding a line about how knowledge dissolves into meaning the way comas dissolve into tales, but you don't. They already know. They were here. You think of time as a corridor filled with dim lamps, Galileo polishing glass in 1609, Huygens clocking Saturn's rings, Caroline Herschel sweeping comets with a hand that refused to tremble. Somewhere in that corridor, you and 3i Atlas passed, neither stopping, both acknowledging, both continuing. The lamps flicker, the hallway lengthens. Scientists still argue whether humility counts as a method. You decide that it does. You turn off the monitors, check the locks, and step into the cold where the sky is once again unsupervised. Above the ridge, the Milky Way looks like frost blown from a sleeping giant's mouth. In that pale drift somewhere, the object you have loved with disciplined attention is already smaller than imagination, but larger than forgetting. If it is natural, it will fade. If it is artificial, it will change everything. If it is both, well, then it is kin. You start walking down the path, stones crisp underfoot, tea still warm in your palms, a good, tired building behind your ribs. It occurs to you that all along you were not chasing Atlas. You were pacing your own attention, learning how to move without hurrying, how to study without hardening, how to let the mind measure while the soul listens. We measure the distance, we chart the orbit. But what we're really chasing is understanding. And on nights like this, when the last green fades into arithmetic, you understand enough. Let the pacing soften now. Let the vowels lengthen. Let the room cool by a single quiet degree. You can feel the body remembering what the mind forgets. That rest is a kind of astronomy too, a slow orbit back toward home. Picture the sky as a lake at midnight. No wind, no ripples, only reflections. Stars like small towns far across a calm water. Somewhere beneath that dark surface a traveler has passed, and the water has already healed. The wake is gone. The journey remains. Breathe once, deliberately, count 4 in, 6 out. Feel the ribs drift apart, the shoulders unhook, the jaw unclench. The day recedes behind you the way sunlight recedes beyond the orbit of Mars. Still real, simply distant. Whatever was urgent grows courteous. Whatever was loud becomes accurate. If a thought returns, let it. Give it a seat near the window and watch it drowse. You don't have to resolve it tonight. Even the sun rests behind the horizon, and still the world holds. What needs your attention will circle back in the morning, like a planet keeping its promise. Imagine 3-Eye Atlas as a small, patient lantern moving outward along a road of frost. Not vanishing, just continuing. The light is faint, but it is sufficient for everything it must do. So is yours. In a moment, you'll sleep. The instruments will keep their quiet vigil. The stars will keep their older one. Somewhere an archive drive hums faintly, and in that sound is reassurance. The story is saved. The data is safe. You are safe. Let the last image be simple. A dark field, a single line of light, and your breath joining it. Steady, slower, gentler, until even the line dissolves into night, and the night becomes a room, and the room becomes rest. Good night, traveler. The sky will still be here when you wake. End of script. Sweet dreams. Let the pacing soften now. Let the vowels lengthen. Let the room cool by a single quiet degree. You can feel the body remembering what the mind forgets. That rest is a kind of astronomy too, a slow orbit back toward home. Picture the sky as a lake at midnight. No wind, no ripples, only reflections, stars like small towns far across a calm water. Somewhere beneath that dark surface a traveler has passed, and the water has already healed. The wake is gone. The journey remains. Breathe once, deliberately. Count 4 in, 6 out. Feel the ribs drift apart, the shoulders unhook, the jaw unclench. The day recedes behind you the way sunlight recedes beyond the orbit of Mars. Still real, simply distant. Whatever was urgent grows courteous. Whatever was loud becomes accurate. If a thought returns, let it. Give it a seat near the window and watch it drowse. You don't have to resolve it tonight. Even the sun rests behind the horizon, and still the world holds. What needs your attention will circle back in the morning, like a planet keeping its promise. Imagine 3-Eye Atlas as a small, patient lantern moving outward along a road of frost. Not vanishing, just continuing. The light is faint, but it is sufficient for everything it must do. So is yours. In a moment, you'll sleep. The instruments will keep their quiet vigil. The stars will keep their older one. Somewhere an archive drive hums faintly, and in that sound is reassurance. The story is saved. The data is safe. You are safe. Let the last image be simple. A dark field, a single line of light, and your breath joining it. Steady, slower, gentler, until even the line dissolves into night, and the night becomes a room, and the room becomes rest. Good night, traveler. The sky will still be here when you wake. End of script. Sweet dreams.